In general, here are the properties for the general solutions for arcsine, arccosine, and arctangent. Let A stand for the argument of the inverse sine, cosine, or tangent. Then theta will be equal to arcsine of A, and that would be equal to sine or arcsine of A plus 360 degrees n, or 360 degree and degrees also, or equal to 180 minus sine or arcsine of A plus 360 and degrees. So these are the two solutions. Okay, these are the two forms of the solutions. Or in terms of x, when we are dealing with regions, that would be arcsine A plus 2 pi n, or pi minus sine or arcsine A plus 2 pi n. Okay, and verbally inverse sines come in supplementary pairs plus coterminals. So those are the solutions for the general arcsine expression. Visually reflect the reference triangle across the vertical axis. So these are the conclusions and the properties of arcsine. And for arccosine, theta is equal to positive negative cosine or arccosine A plus 360 degrees n. And x is equal to positive negative cosine negative 1 or arccosine A plus 2 pi n. Verbally, inverse cosines are in opposite pairs plus their coterminals, and visually reflect to the horizontal axis. For arctan, theta is equal to arctan A plus 180 degrees, and for a radian version, arctan A plus pi n. Verbally, inverse tangents come in pairs a half revolution apart, so it's like 180 degrees apart. Visually reflect the reference triangle across both axes. Okay, let's go to the quadratic forms for example 3. Solve algebraically. Cosine square theta plus sine theta plus 1 is equal to 0. Okay, so our element here, or our domain here, is from negative 90 degrees to 270 degrees. So to start with, let's write down the equation. It's cosine squared of theta plus sine theta plus 1 is equal to 0. And the interval of the theta is in between negative 90 degrees and 270 degrees. So since our sine theta is in its elementary form, meaning it's in an exponent of 1, then what we can do here is to express our cosine squared of theta into sine squared of theta. So this would be 1 minus sine squared of theta. Because by doing so, by expressing this cosine squared of theta into this expression, then all that we have left here is in the expression of sine theta. Okay? So we could now find for the value of theta, because our our equation is in terms of the sine theta functions or expressions. And then this would become, we will have 2 plus sine theta, arranging from the least to the greatest exponential form. That would be like that. Okay, and this will give us, sine of square of theta. So if we are going to multiply negative for each of the sides, which we can do actually, so we have to multiply both sides by negative 1. Now we multiply both sides by negative 1 to express this entire equation from a greatest exponent to the least exponent, so that we will have sine squared of theta minus sine of theta minus 2 is equal to 0. And by factorization, this will give us sine of theta minus 2 is equal to, and sine of theta plus 1 is equal to 0. Now let's see if we have values for the given factors. So sine of theta is equal to 2. Do we have a value where sine of theta is equal to 2? Definitely not. So this has no solution. So we cross this out. Okay? Remember that the sine function oscillates from 1 to -1. The parent cosine function y is equal to sine theta has the greatest amplitude at 1 and the lowest amplitude at -1. So there is no way that our sine theta could reach 2. Therefore, this is not included as a solution. So this crossed factor indeed has no solution. So we are left with the other factor. And that factor, okay, that factor is for the sine theta plus 1 is equal to 0. Okay, and that means that we have to get the value of the other factor. So we have sine of theta plus 1 is equal to 0. So we have sine of theta is equal to -1. And theta will be equal to arcsine of -1. So following the form or the general solution for arcsine, arcsine is a general solution which is arcsine of A plus 360 degrees in this case, and because we have theta. So what is the general equation for the solution? We have theta is equal to arcsine of A plus 360 degrees n. Okay, so let's find our first solution. Okay, now sine -1 of -1, or that means that we have arcsine of -1 will be equal to arcsine of -1. 1 negative inverse arcsine. So that is 90. Okay, so we have a first solution of 90 degrees. And it's still included in the domain. Okay, what else? Can we put, if our n is equal to 1, that means that we have 360 degrees times 1 plus 90 degrees, but it will be over the interval already, so we cannot use any n is equal to 1. Okay, so theta is equal to 90 degrees when sine or arcsine of -1 is equal to -1, and that means 1 negative inverse sine. So that's this is negative. Okay, negative 90 degrees, and negative 90 degrees is also equal to 270 degrees, right? But if we are going to write it here, that would be 360. So plus 360 for n is equal to 1. That would be 270, but 270 is out of our domain. So the only solution left here is negative 90 degrees. Okay? So this is negative 90 degrees. It's the only solution that we have here. Okay? So again, be very careful with general solutions. You have to memorize this. But if you are already, you know, good in the trigonometric functions, you can also use bypassing these given solutions, and you can think of other ways to solve uh, the given equation itself by relying on the common sense and as well as logic. So aside from that, you have to work on the problem with the understanding of these trigonometric functions, especially the locations of positive or negative of the functions, as well as a manipulation of those reference angles. So those help. So numerical solutions. What about numerical solutions? Now some trigonometric equations cannot be solved in terms of algebra. So this is true if the variable appears in the argument of a non-algebraic function, such as y is equal to sine x, and in an algebraic equation such as the one that is being written here. So this is actually what do you call this? It's an algebraic expression. So you cannot transform the equation to the form f of x, right? Is equal to constant. So in other cases, the solution may be difficult to find. So in this case, you can see that the solution is difficult to find here. So what we need to do here is to find the intersections of f of 2x to a certain function of the variable, such as this case. This is actually intersected. We have f1 of x is equal to 0.2x plus sine x, and f2 of x is equal to 2. So doing the intersection for both gives this equation. Okay? And to solve by numbers, you can use the intersect or solver feature on your grapher. So you have your grapher, there is a solver feature. So just intersect the two equations here, or the two functions here, f1 of x and f2 of x. And you could see that the graph of these two functions will give you an insight on the locations. Now this is also equal to y is equal to 2, right? And this is another function, and this function has its own graph, and this function also has its own graph. So using the solver feature of your grapher, it can solve this equation, okay, by pressing on the solver feature. Well, it's the solver feature of the grapher. So you have your grapher. Let's intersect. It will show you the graph, and it will show you some of the numbers wherein these two are intersected. Okay, so in this case, in your book, the possible values of x are 6.9414 for the original, for the graph itself, and 9.2803, 12.1269, or those are approximately 7.0, 9.3, and 12.1. So this is what we call the numerical solutions. You can use the graph instead because it's difficult to find a solution using algebra, such as in this case. Okay. So the answer is 0 or approximately x is approximately 7.0, 9.3, and 12.1. Okay? So let's go now to problem set 7-4. Let's start with problems 1 to 10. Now in problems 1 to 10, I only selected two numbers, which are numbers 2 and 7. So letter A, for these two equations, we have to find the general solution for theta or x. Remember, for theta, the answer should be in degrees. And for x, it should be in radians. So either radian or degrees. And also, if you happen to have the radian and the degrees, then you have to set your calculator mode into either radian or degrees. So in this case, let's do number 2. Okay, let's set this box for number 2. Theta is equal to arcsine negative 0.6. So find the general solution. That's the first condition here, is to find the general solution. And A, this would be theta is equal to arcsine, or in simpler wording, it would be sine raised to negative 1, negative 0.6. And the general solution for this would be plus, just add 360 degrees, or n degrees. Okay, so letter B, find the particular solutions that are in the given domain. So the domain of our first equation is 0 and 720 degrees. So let's say when our n is equal to 0, so if n is equal to 0, then theta would be equal to, let's use degrees here, so that would be 0.6 negative inverse sine, okay, plus 0. So we cannot use this because this is negative, okay? Negative 36.8698. We cannot use this. So we have to find when n is equal to 1. So when n is equal to 1, well, is this the general solution? I think there is another one. There's another one. So it's 180 degrees. Okay. Yeah, I forgot to write the other one. The other one is actually theta is equal to 180 degrees minus arcsine of negative 1, negative 0.6, plus 360 in degrees. So these are the two general form of the solutions. So we are B, we go back to letter B. Okay. But since we don't have much time here, we will continue this on the next video.